Hello everyone and very good evening. I hope you all are doing well. So today actually weather is not good here. Current is not there from long time. Weather is quite windy and everything. So sorry if you're not able to see the video perfectly. But yeah, class will go on like normal. So from today we are going to start electrostatics. Done hai? So let's start the thing. What we are going to study, सबसे पहले हम लोग पढ़ेंगे we will be reading types of charges, ठीक है, and then we will read properties of charges and then we will read method of charging, ठीक है. So these are the very basic thing that we can learn in electrostatics. So let's start with a very much basic, ठीक है. So let's start with it. So basically we encounter three things, that is since we are learning about charge and everything, so proton is there. We already know, like when you talk about atom, there is nucleus, and then it has different house number, that is cell number. Then in these cells, electron resides, and inside nucleus there is proton and neutron. So basic charges that we see in us, not see that we know in our surrounding is proton and electron, right? So proton has a mass of around 1.67 into 10 to the power minus 27 kg. You don't need to remember it because as we will move forward with classes up to modern physics, it will stay in our mind like anything. Okay? The way you remember your name. So it will become that much common. Now, what is the value of charge? You all must be aware of it. 1.602 into 10 to the power minus 19, जिसको हम short form में क्या लिखते हैं? 1.6 into 10 to the power minus 19 coulomb. What is this coulomb? This is basically SI unit of charge. Done it? We all know neutron. Neutron carries same mass as that of proton almost, and it is a neutral body. There is no charge on it. And then comes electron. Electron has a lesser mass. This is almost 1 into 10 to the power 6 times smaller in with respect to mass with the proton. Okay? So when you compare the mass of proton and electron mass is smaller by 10 to the power 6 times. Okay, and both proton and electron carries the same value of charge. इसको हम क्या बुलाते हैं? 1.6 into 10 to the power minus 19 coulomb. ठीक है? So these are very basic thing. You should be aware of it. Now, what are the properties of charges? This we are going to explore. कुछ properties you all must be aware of. You all must be knowing it already. So first thing is like charges repel. ठीक है? So if there are two positive charges, these positive charges when they are in their surrounding, what will happen? They will repel each other. Okay? And when there is positive charge, जैसे you take one proton, one electron, then these two will attract each other. So if there is proton, there is electron kept at certain finite separation, then proton will start moving towards electron will start moving towards proton, right? If we have two electron, then naturally what will happen? Electron will move away from another electron. This electron will also move away from another electron because repulsion is happening. Repulsion का simple meaning ये होता है, charges are not getting attracted towards each other, they are getting repelled. ठीक है? So this is the thing. Now, second property is charges are quantized. What does it mean? Quantization का मतलब क्या है? So simple thing is that smallest value of charge that we are going to read is charge on electron. That is equal to what? 1.6 into 10 to the power minus 19 coulomb. So much research has happened, and there are also particles which carry charge less than that of electron, but that is beyond our syllabus. In our syllabus, we will be remembering the smallest charge that a particle can carry is equal to charge on electron, and that is equal to 1.6 into 10 to the power minus 19 coulomb. And this second property says that whatever charge we are going to encounter, that will be integral multiple of this E. Done it? So if certain particle has charge E, then another particle can have charge 2E, 3E, 4E, 5E. It means it will be integral multiple of electron. Done it? So this is the meaning of charges are quantized. Then all this is like there is so much violation of this thing. Just now I said you some research happened where quark is one thing which carries charge less than that of electron e by 3 or something, right? So but that is not in our syllabus. We have to follow up to this. Okay, chalo. Now what is third thing? Charge is conserved. अब देखो, these are very simple thing, but still conceptually, I mean, concept thing will start from here only. Jaise, here there is one term written, that is your isolated system. What is the meaning of isolated system in electrostatics? So electrostatics का मतलब आप लोग समझ रहे हो ना? Sorry, I forgot to explain the title. So electrostatics का मतलब electro means electron और electro means charge and statics का मतलब क्या होता है? Rest. So in this topic we are going to read charges at rest. That is electrostatics. I'm really sorry for that. अब देखो what is the meaning of this isolated system? Isolated system का मतलब ये होता है system which is not connected to any battery. You all must be aware of battery. What function does battery do? जैसे when you connect battery to certain things, battery supply charge. It supplies energy. Charge भी supply करता है. So if some system is not connected to battery, what does it mean? It has a simple meaning that it will receive no charge from outside. Agar there is some metallic thing and it is not connected to any other battery. Suppose kar lo, I have a solid sphere, conducting solid sphere. I have given charge to it plus q charge I have given to it, which is integral multiple of the electron. I don't know what is the amount. Let's say plus q is the charge given on this metallic conductor. ठीक है? And I'm not connecting this metallic conductor to any battery. It's not connected to any battery. Then what you can say, charge on this metallic conductor over time will remain same as plus q. It is not going to change, right? Why it is not going to change? Because it's not connected to any external source, which can either supply its extra charge or which can either take its extra charge. जैसे अगर आप मेटेलिक कंडक्टर को अर्थ से कनेक्ट कर देते हो, देन यू ऑलरेडी नो अर्थ इज अ कंडक्टर, राइट? सो it is highly possible that earth will I mean it will attract all the charge of metallic conductor to itself, and in that case metallic conductor may get neutral. ठीक है? But when our system is isolated, means it is not connected to any battery, it means it is not connected to any other conducting systems. ठीक है? So I hope it is clear isolated का मतलब. So when the system is isolated, total charge is always same. It is always conserved. So यहाँ पे system isolated है. On this metallic conductor, charge at any time will be always equal to plus q. Done है? देखो charge conservation का एक meaning और है. I mean we will read it later. I mean we will do questions also. So suppose कर लो यहाँ पे एक metallic conductor है, we have given plus q charge to it, and then there is another metallic conductor, ठीक है? And this metallic conductor is getting connected with this metallic conductor through a conducting wire. Then what will happen? Charge from this metallic conductor will get transferred to B metallic conductor, ठीक है? And what is going to happen in that case? Let's say charge transfer happened such that on A total charge now remaining is Q1, on B total charge is Q2. So we can easily say here Q1 plus Q2 will be plus Q. है ना? Because initially only metallic conductor A was having charge how much? Plus Q. Now A is having charge Q. Is having charge Q2, it means only plus Q got divided, some on A and some on B. ठीक है? कुछ तो A पे रह गया और rest got transferred to B such that Q1 plus Q2 is plus Q. So this is called charge is conserved. Conservation of charge thing. ठीक है? Now charges are transferable. Fourth property, जैसे जैसे अभी मैंने बताया कि there is a metallic conductor having plus Q charge. And if we are connecting this metallic conductor with another conductor, then what will happen? Charge transfer will occur. So charges are transferable. We can transfer it. And this is highly possible. This is fourth property. Okay, up to this, anyone is having any doubt? Let me know. There is a storm sort of situation over here. That is why there is so dark weather, and also there is no electricity from very long time. And that is why I'm having this issue. So, okay, Sunil, thank you. So forgive me if I'm not able to present properly the video. Content must be clear, right? Anyone facing any issue? If yes, let me know. Anyone? कोई नहीं? चलो ठीक है, ठीक है, ठीक है. मोनिका, thank you. Okay, done है. Somebody said 0.3. 0.3 क्या था तुम्हारा? 0.3 was charge is conserved. देखो, charge is conserved has a simple meaning. इसका मतलब ये है कि if you have a conductor and on this conductor if there is any charge, let's say it has 8 coulomb of charge. ठीक है? So if this metallic conductor is isolated, it means if it is not getting connected to another conductor, if it is not getting connected with any source, कहने का मतलब any battery, then charge on this metallic conductor at any time will remain equal to 8 coulomb. And this is called charge is conserved. Energy conservation padhe ho na? What happens when mechanical energy is conserved? When ball falls from certain height, what happens? Its potential energy decreases and that gets converted into kinetic energy such that total energy is same. That is conservation. Here also what is happening? There is a certain charge on a metallic conductor. It has 8 coulomb of charge. If it is not going anywhere, then charge on this metallic conductor will remain same. How it can go anywhere? By when it is connected to another conductor through conducting wire, or when it is directly connected to some conductor like earth, done it, or when it is connected to some battery. If you are connecting it with battery, then battery may supply it some extra charge. It may happen, right? So if none of the case is true, then charge on this sphere will remain constant. And that is called charge is conserved. ठीक है? जैसे एनर्जी कंजर्वेशन का भी सर्टेन कंडीशन होता है. फ्रिक्शन इज नॉट देयर, ड्रैग फोर्स इज नॉट देयर, विस्कस फोर्स इज नॉट देयर, एयर फ्रिक्शन इज नॉट देयर, then only we conserve things, right? So that is the point. Any got it? Okay, Nikita. Okay, you only asked it, right? Now we are going to read method of charging. So in method of charging, we have three methods by which we charge conductors. One is called conduction, another is called induction, another by friction we can do. Okay. So first we will see how we can charge things by friction. You all must have experienced one thing, like when you have applied what I mean oil on your hair, and if you rub your hair with pen or something or comb or something, and if you take that rub pen near the bits of paper, then paper appears to rise up, right? Yes. You have some doubt? कोई doubt है? Okay, let me know if you have doubt in chat section. ठीक है? चलो. So what happens there? Paper gets attracted towards the comb, right? Janvi, Haveri. Okay. Done it. So what happened there? You are taking comb to the hair, you are rubbing it. So by rubbing, we can allow charge transfer to happen. That is called charging by friction, basically. So there is but one condition: only non-conducting materials can be charged by rubbing with neutral bodies. Okay, only non-conducting. Because when you are rubbing things, what happens? Suppose Karlo, you are the person, and I'm very bad at making diagrams. Let me tell you first. So maybe I will be making most horrible diagrams. So this is a person. This person is holding comb in its hand. So this is your comb. And what he did is he rubbed his hair with this, so it got some charge. Let's say this comb is metallic comb. This comb is what? Metallic. Metallic का मतलब क्या होता है? This is a conducting comb. And if it is conducting, then as charge will develop on this, जैसे ही develop होगा, this charge will get transferred to our body because we are conductor. We are what? Conductor, क्योंकि we are made of water and something, right? Water content in our body is more. So we are conductor. Okay. I'm not getting your question actually. Maybe in the case of water you are trying to say, I'm not able to get it because of gravity that may happen. So what I'm trying to put here is you can only charge things by friction if the material is non-conducting. Why with conducting it is not possible? Because when you are rubbing conducting things, yes, it will develop charge, but that charge will instantly get transferred to you, and you are standing on the earth. Earth is also conductor, and ultimately through you, this charge will get transferred to earth. Done it? So what will be the end result? End result is that this conducting comb will not be able to retain any amount of charge. So definitely it's not, it will appear like it's not getting charged. Okay. But if we have non-conducting comb, in that case, what will happen? If it is if you're rubbing it with against your hair, it will develop certain amount of charge. Let's say it is developing positive charge, and then then it is charged. Then initially our comb was what? Uncharged. Now you are rubbing it and it is getting positive charge. So by rubbing, you are creating charge. Yani ki charge transfer is happening. So you can charge a body by friction. Condition is that body should be non-conducting. If it is conducting, charge won't be able to retain, won't be able to stay on that particular body because through you it will get transferred to earth. Okay, I hope it is clear. Everyone clear with this point? Okay, ठीक है. I will be pronouncing your name as Grace, okay? If you don't mind. Okay, Sunil, thank you. Chalo. Now, what is charging by conduction? So, in charging by conduction, what things we are going to do is, see here, this is a neutral body, and we have to charge this. Suppose, done it. So, we are going to use now conduction method. So, in conduction method, you need one body which is already charged. ठीक है, हमारा requirement क्या है? First, you need one body which is already charged. So here I am taking negatively charged body. ठीक है, and then you need to take another body which you want to charge. So let's say we want to charge this ping pong ball. We want to charge this ball. Then what we are doing now, we will, we will, okay. Yes, I'm looking at chat. I can see your chat. What happened? I have looked at everyone queries. Nothing is left. I don't know why you felt like I'm not able to catch up with the chat section. Maybe, maybe you must have sent some message, you couldn't reach me. Where is your question? But from JNB Haveri, I'm getting. Okay, just now you say you sent it. Okay, okay, done. Because at the same time I got so many messages, maybe that is why. Okay. If you are rubbing conducting object rubbed with non-conducting object, same thing will happen. I mean, your question is, there is a conducting thing. So your hair is what? This is non-conductor, right? So there is a conducting thing and you are rubbing it with non-conducting thing, you are saying, right? Even if this is the case and you are holding it, because when you are rubbing it, you are holding things. Done it? In one hand, this conducting thing is there. In another hand, this non-conducting thing is there. And you are rubbing it like this. So if you are rubbing it, this conducting will develop certain charge. And then what will happen? This this charge will get transferred to the wood. Because uh, देखो, non-conducting materials can be charged, but what's your question? Sorry. Let me look at the question again. ओके, कंडक्टिंग को नॉन कंडक्टिंग से कह रहे हो, ठीक है। और मैंने क्या बोला, नॉन कंडक्टिंग मटेरियल्स कैन ओनली बी चार्ज, conducting cannot be charged. That was my thing, right? So even if you are rubbing, your point is correct. अगर आप conducting को non conducting से कर रहे हो ना, तो whatever charge will develop on conducting, that will be not able to retain charge, that through your body will get transferred to earth. But yes, whatever charge got developed on non-conducting during the process of rubbing, yes, that charge will stay on non-conducting. That is why I said only non-conducting material you can charge by friction, otherwise you cannot. That was my point. With gloves in hand, yes. Gloves you are saying, or gloves you are saying. Yes, if you're taking non-conducting gloves, then it's possible. Yes, you're able to get it. I said only non-conducting material can be charged because only non-conducting can retain charge on itself. Conducting will also get charged, but within fraction of second, it will transfer that charge to the earth through us. But if you're wearing gloves or something, so that will make it sure that charge is not getting transferred. So in that case, yes, conducting को भी कर सकते हैं, but with bare hand we cannot do. ठीक है? That was my point. You didn't get it. Monica, metallic conductor won't always carry positive charge. It can also carry negative charge. It's not always the case. जैसे आप लोगों ने पढ़ा है, metals generally it has tendency to lose electrons. So in most cases it will have positive charge. But there are some methodology जिससे कि you can make sure you are storing negative charge on conductor also. Done it. But naturally, yes, metallic conductor will lose electron and have positive charge on their surface. ठीक है? यस, समझ में नहीं आया तो चलो मैं फिर से समझाती हूँ। मैं ये कहना चाह रही हूँ कि देखो, व्हेन वी रब थिंग्स व्हाट हैपन, चलो लेट्स डिस्कस इट थ्रू केमिस्ट्री। व्हेन यू रब थिंग्स, जैसे हमारे पास दो एटम है, एटम ए ले लो और एटम बी ले लो, ठीक है। सो लेट्स से दिस इज अ मेटल एंड दिस इज नॉन मेटल, ठीक है। दिस इज मेटल, दिस इज नॉन मेटल, यू आर रबिंग दिस टू मेटल्स टुगेदर। डन है। So rubbing का मतलब क्या होता है? You are generating heat, you are giving it energy, and you know about ionization energy. You know, right? If there is atom and if you have to pull one electron out of the atom, you supply it certain energy equal to ionization energy, then electron will come out. ठीक है? So if during rubbing process enough heat is getting generated such that that energy is equal to ionization energy, then A being metal will have tendency to lose electron. So let's say it's losing electron, and that lost electron it will give to what? B. So here B is developing negative charge, A is developing positive charge. And since this is your metal, you are holding it. If you're holding it in your hand, that charge will get transferred to the earth. So only charge remaining will be on which thing? Uh, only charge remaining will be on B. So that is why I said only non-conducting material you can transfer. But when you're saying if you're holding metal A with gloves, non-conducting gloves, then definitely A will also develop charge, B will also develop charge. It is that simple. You don't need to, I mean, put in this much focus into this. Just understand when we rub things together, we charge things. Why? Because during rubbing, we are generating energy. If that energy is equal to ionization energy, things will get charged. Now the thing is, if you are holding two things with bare hands, only non-conducting material will retain charge. Conducting will lose it. That's my point. Am I able to explain it? Jane B. Haveri. Is it clear now? Weather is too bad here. Yes. Is it done? Sahana, no ma'am. What you didn't understand? Can you unmute yourself? Okay, let me. Okay, Jane B. Haveri. Sahana, what's your problem? What you couldn't understand? Raise your hand, please, so that I can unmute you quickly. Yes. Yes. I have asked you to unmute. You can unmute yourself now. आप बताओ क्या डाउट है? Okay, somebody else has raised their hand. चलो ठीक है. Who is this? ठीक है. Okay, you can unmute yourself now. Let me know what's your doubt. Yes, Sahana, I'm audible. But you said no, you didn't understand. No, ma'am, you have written. So I felt like you're having doubt. Is it so? Or you were trying to say something else? Okay, you understood. ठीक है, ठीक है. Thank you, thank you, thank you. Sorry, I got confused. So in the method of conduction, what we are going to discuss, in method of conduction, we do charge another body with the help of, I mean, in this method, we have two bodies. One body is already charged. Another body is what? Neutral. So what we do here, we simply make charged body touch the neutral body. And during this touching process, what happens? During this contact, what happens? Charge transfer occurs. Because both are conductors. ठीक है? So यहाँ पे ये तुम्हारा conductor है. Since this is conductor, charge, it will transfer its charge. Done it? And it will go here like this. ठीक है. सो चार्जिंग इन कंडक्शन में क्या होता है? बोथ हैव टू बी कंडक्टर्स. दोनों को कंडक्टर होना जरूरी है, सो दैट वन कैन गिव चार्ज एंड अनदर कैन अलाउ दिस चार्ज टू स्प्रेड ऑन इटसेल्फ. अगर ये नॉन कंडक्टिंग है तो चार्ज स्प्रेडिंग नहीं होगा. ठीक है. सो इट हैज टू बी कंडक्टर चार्ज ट्रांसफर के लिए. ठीक है. कॉन्टैक्ट इज रिक्वायर्ड. इफ नो कॉन्टैक्ट नो ट्रांसफर विल हैपन. क्योंकि अगर दूर दूर है दो चीजें, एक पे चार्ज है, दूसरा यहाँ है, तो बीच में एयर है. एयर इज इंसुलेटर, राइट? So this air will not allow this positive charge to go and sit on B. For that, you have to either connect it through conducting wire or either you have to create contact. So here we are doing it through contact. Okay. So the second thing is that both objects acquire the same type of charge. Yes, because the body which was charged has negative charge and we are giving same charge to another body. So both will ultimately have the same charge. Done? So same charge is getting transferred. Charging body lose charge. Obviously, one is giving its own charge to another, so it will lose its charge. So charging through conduction में क्या होता है? Contact is required. Both have to be conductors, and both objects acquire the same type of charge. Charging body is going to lose the charge. But overall, if you talk about conservation, then these two body will have always charge conserved. Done, because one is losing, another is gaining, such that whole amount is remaining constant. Okay, this is the thing. Now there is another method that is called induction. Okay, so how we charge things through induction? Let's have a look over it. So this is a neutral metallic cylinder and this is a ebonite rod which has charge on itself. Now what we are doing is when you are bringing them in electric field, then I mean electric field will allow charge to move, है ना? So इलेक्ट्रिक फील्ड को अगर आप रखते हो, जैसे what you are trying to say कि अगर यहाँ पे इलेक्ट्रिक फील्ड हो and in that electric field you have kept this charge here, you are saying this, right? And then there is another neutral conductor, so you are saying because of electric field charge will get transferred. Do you think so? Hmm? You really think so it will happen? ओके, बट इट शुड नॉट हैपन लाइक दिस. क्योंकि जैसे देखो इलेक्ट्रिक फील्ड को जब हम पढ़ेंगे, सो फील्ड इज व्हाट? फील्ड बेसिकली देखो, जब फील्ड पढ़ाऊंगी देन आई विल डिस्कस इट मोर. फील्ड सिंपली टॉक्स अबाउट प्रेजेंस ऑफ अनदर चार्ज. देन इफ आई एम ड्रॉइंग हियर फील्ड, इट इसका सिंपल एक मतलब है कि देयर इज चार्ज इन द सराउंडिंग. जैसे यहाँ पे प्लस क्यू चार्ज है, इट विल हैव अ इन्फ्लुएंस इन द सराउंडिंग रीजन. Electric field is not any physical, has no physical significance. Electric field we draw for our understanding. Okay. So basically this positive charge has influence in the surrounding, and that influence we show pictorially by drawing electric field. और अगर इसके सराउंडिंग में दूसरा चार्ज है तो ये चार्ज इस चार्ज को अट्रैक्ट करेगा. सो ओवरऑल बॉडी का मोशन हो सकता है. जैसे यहाँ पे ये बॉडी है प्लस क्यू, इस पे चार्ज है और यहाँ पे एक प्लस क्यू चार्ज है, यानी कि इसकी वजह से इलेक्ट्रिक फील्ड है. तो इफ दिस प्लस क्यू चार्ज इज वेरी स्ट्रॉन्ग इट विल अट्रैक्ट दिस मेटालिक कंडक्टर, बट इट डजंट मीन charges from here will start flying randomly. No, it won't happen. ठीक है, क्योंकि पॉजिटिव चार्ज का मतलब समझ रहे हो ना तुम लोग. पॉजिटिव चार्ज का क्या मतलब है? पॉजिटिव चार्ज का मतलब है कि एटम हैज लॉस्ट इट्स इलेक्ट्रॉन, है ना. डन है. सो it won't happen like positive charge will start flying because of presence of electric field. Attraction will be there, but charge transfer as such won't happen in that way. Yes. Is it clear? Here they are like charges, they will repel. Sorry. Yes, here they are like charges, they will repel. But अगर negative ले लूँ मैं तो they will attract, right? If I'm taking negative charge, then they will attract. But physical attraction will happen. It's not like charge will fly and get onto that place, right? Sorry. Done it? Okay. We will read more electric field. We are just starting, ठीक है? सो इंडक्शन में क्या है, देखो सिंपल सिंपल मेथड्स है, वो मैं तुम्हें दिखा देती हूँ. ये ज्यादा इंपॉर्टेंट टॉपिक नहीं है, बट स्टिल यू शुड अंडरस्टैंड चार्जिंग कैसे होता है. ठीक है. सो दिस इज वन रॉड हियर विच इज चार्ज पॉजिटिवली चार्ज. दिस इज न्यूट्रल मेटालिक सिलेंडर. What is happening here? Step one, we are bringing this positive charge closer to this. We are not bringing them in contact. We are not establishing contact. ठीक है, just pass लाया है. And since this is a metallic conductor, this is a metal, right? So metal के पास क्या होता है? It has free charges. So whatever negative charges, free negative charges it has, will get attracted to this end because positively charged rod you have brought closer. So negative charge will come here, and what will happen? Yes. Which is neutral? Sorry, Ebord, something you wrote, I couldn't understand. Yeah, that is neutral. Second one is neutral. ठीक है. But any metallic thing, green one, yes, that is neutral. So whatever is conductor किसको हम कहते हैं? Conductor is something that can carry free charges. Sorry, actually I'm getting distracted. I'm really sorry. ठीक है. कंडक्टर का मतलब क्या होता है? कंडक्टर का मतलब होता है समथिंग दैट कैरीज, I mean that has free charges, not bound charges, I would say. Again, that is a very deep study, micro level का study है, that we don't have to do. But so far, what we have to remember is, if you, yes, ebonite में क्या जानना चाहते हो मुझे बता दो. Have I spelled it wrong? You can correct them. ठीक है. So if something is metal, it has free charges, free negative, free positive charge. You can understand in layman term like this. ठीक है. But overall it is neutral because it has three negative charge, three positive charge. So overall adding you will get zero charge, right? So when something is conductor, it has free charges available, negative and positive. Done. So similarly, this conductor, this metal has free charges. Negative will get attracted towards the rod, and positive will get repelled. So it will lie as far as possible. कितना दूर तक जा सकता है? इतने दूर तक ही जा सकता है, क्योंकि इससे दूर जाने का मतलब है it will leave the conductor, which is not possible, right? So it will stay here like this. अब देखो हमने इसको ऐसे रख दिया. ठीक है. Now what you have to do? Now we are going to connect this thing with the earth. Then the moment we will connect this green sphere with the earth, what will happen? This positive charge will flow to the earth. Then, and this negative charge will not be able to flow to the earth because this is bonded by this positive rod. ठीक है, पॉजिटिव रॉड इसको बांध कर रखेगा, है ना, it will keep it attracted towards itself, and that is why it is not able to go to the earth, but this plus is getting repelled by rod, so it will get attracted by earth very easily. ठीक है, after this is done it will look like this. ठीक है, अब हम क्या करने वाले हैं, now we will remove earthing, so now we are going to remove it. So if we are removing earthing, it will look like this, negative charge is still here. Now you remove the rod, take the rod from the take the rod as far as possible so that it is having no effect on this green sphere. Then what will happen? Whatever negative charge was here, it was here because it was attracted by this rod. If you're removing this rod, it is no longer in attracted state. It will get uniformly distributed. So this green sphere is getting uniformly charged. Okay. Okay, Janvi, Haveri, I will try. Okay, I will try doing this. ठीक है, चलो, तो पहले से चलते हैं, जिसको समझ में नहीं आया उसको स्टेप 1 से लेकर चलती हूँ. वी हैव वन रॉड, just let's make it simple. It has a positive charge. We have another neutral conductor. ठीक है, neutral conductor है, इसका मतलब it has free charges, and free charge can be of positive and negative nature, but as much positive charge is there, that much negative charge will be there. ठीक है, अब आप यहाँ पे देखो, हमने पहले स्टेप में क्या किया, वी ब्रॉट दिस रॉड क्लोजर टू द मेटल. when if we are bringing it closer to the metal, what will happen? Its free negative charge will get attracted towards the rod, and its free positive charge will get repelled to the other side. This is happening. ठीक है, इसके बाद हमने क्या किया, इसके बाद we are doing one thing. We are conducting this end to earth, that is we are connecting it with earth. earth Earth is a conductor. It will attract this positive charge towards itself. ठीक है, but it will be not able to attract this negative charge towards itself because ये negative charge is positive से bonded. ठीक है, because this positive charge, this negative charge is bonded by rod. So this system is a bonded system. This is a free system. This is getting already repelled. So once it is getting some conducting thing, it will get transferred because it has tendency to go as far as possible, right? So it will go to earth, and after that things will look like this. Now still it is this negative charge is bonded by this positively charged rod. Okay, so what is going to happen over here? Now first remove the earthing, don't first remove the rod, क्योंकि जैसे ही आपने पहले रॉड को अगर रिमूव कर दिया ना, सो नेगेटिव चार्ज को अभी भी अर्थ के पास जाने का मौका मिल जाएगा. ठीक है, सो फर्स्ट यू रिमूव द अर्थिंग. डन है, सो व्हेन वी रिमूव द अर्थिंग, ये सिस्टम कुछ ऐसा हुआ. अब आप रॉड को दूर ले जाओ. सो नाउ इफ यू आर टेकिंग रॉड अवे, व्हाट विल हैपन? दिस नेगेटिव चार्ज विल गेट यूनिफॉर्मली distributed. ठीक है, this thing is going to happen. Clear है? Janvi, Haveri? Okay, thank you. चलो डन है. So इंडक्शन में what we studied, only conductors can be charged, है ना, क्योंकि only conductor will have free charges, and then the negative will get attracted towards this end and positive will get repelled like this. So whole phenomena was happening, and it was possible because this green sphere was conductor. Contact is not required. You saw there in the discussion, there was no contact maintained, right? Yes, if negative charge is not attracted, then वो भी transfer हो जाएगा. Yes, डन है. लेकिन इसलिए हमने उसको अट्रैक्ट करके रखा था, so that we can later distribute that negative charge throughout the sphere. डन है, ये नेगेटिव भी अर्थ को जा सकता था अगर ये रॉड पास में नहीं होता तो. ठीक है, So third point is both objects acquire opposite type of charges. जैसे यहाँ पे हमने rod जो लिया था, it was having positive charge. We use this rod to charge this sphere, and this sphere got negative charge. So both are oppositely charged. You can see here. And last point is what? No loss of charge of the charging body. Unlike contact method में, conduction method में, this the rod that was having charge initially was giving its some of its charge to the body, but here no such transfer is happening. So this is not losing any charge, right? This is not losing any charge. Okay, so this thing is happening here. Okay, everyone got clear of this induction thing? या किसी को डाउट है? बताओ. If you are having doubt, you can let me know. क्लियर है? मोनिका, रघुनाथ, साई, ठीक है, थैंक यू. सहाना, thank you so much. Thank you. So these were the very basic thing that we studied so far, and now we will really jump to real things that we have to study more. Okay? So the basic thing that we will read is Coulomb's law. Okay? Okay, Grace, thank you. Coulomb's law, and then we will read permittivity, then we will read principle of superposition. आज के class में I will just discuss Coulomb's law. ठीक है? After that we will close the discussion, and tomorrow we will do more. ठीक है? Thank you so much. Thank you everyone. ठीक है? यहाँ से हम start करेंगे. So what is this Coulomb's law? Coulomb's law basic thing है. If there is charge, if there is one charge and there is another charge, let's say one is positive charge, another is negative charge, and if they are kept at certain finite separation, let's say r, then you already know positive charge attracts negative charge. जानते हो ना? ठीक है? Thank you, Sahana. Thank you. Yes, Janvi Haveri. Yes, Yala Grace. I know your name, but I'm just making it more short. If you don't want me to do that, I will go with the full. Don't, no worries. Yes, Siva. Thank you. Janvi Haveri. You people are trying to say something? No? If yes, then let me know. Okay. So Coulomb's law talked about, we already know one basic thing. If there are oppositely charged bodies, then okay. Thank you. Am I missing on something? You asked something. If neutral body is Earth, then what happens? Nothing. Neutral body has no charge, right? देखो, कंफ्यूज हो रहे हो ना तुम लोग. न्यूट्रल बॉडी ऐसा है, ऐसा न्यूट्रल बॉडी है, इसको अर्थ से कनेक्ट कर दिए. नो चार्ज ट्रांसफर विल हैपन. आई मीन, देखो मैंने बोला ना, दिस इज अ वेरी माइक्रोस्कोपिक लेवल थिंग. अंडरस्टैंडिंग के लिए मैंने बोल दिया कि बॉडी के पास पॉजिटिव मेटालिक कंडक्टर मतलब होता है, इट हैज सम free charges. So I said some positive charges, some negative charges. But if you are trying to think like कि अर्थ से कनेक्ट करेंगे तो ये सारे इधर जा रहे हैं, it's not the scenario actually. समझ रहे हो? कुछ ऐसा है नहीं. आई मीन चीजें हम इमेजिन करते हैं so that I can explain you things in a better way. सिमिलरली इलेक्ट्रिक फील्ड के साथ ट्रू है. इलेक्ट्रिक फील्ड कोई रियल थिंग है नहीं. वी सिंपली ब्रिंग इट इनटू डिस्कशन so that we can make you understand how one charge interact with other. So when we are connecting neutral body to earth, nothing is happening as such. Done it? Okay, thank you. Okay, thank you. You too, have a nice day. But we are still left with class. Okay, stay here. So there are two charges, oppositely directed charges. You already know attractive force will act here. है ना? हमें पता है attract होगा. Sorry, attractive force लगेगा. But now the question is what? Question ये है कि force का value क्या होगा? सो कूलम्स एक्सप्लेन द वैल्यू ऑफ दिस फोर्स. ठीक है, उन्होंने क्या बोला, इस फोर्स के वैल्यू को बताया. सो इफ डिस्टेंस बिटवीन दिस टू चार्जेस आर, then this force first is directly proportional to, let's say this is q1 charge, this is q2 charge. So force is first directly proportional to multiplication of these two charges, then force is inversely proportional to distance ka square, and proportionality constant is equal to k, and we write the force like k q1 q2 by r ka square. So this is your what? This is your force thing. Okay. Now what is this k? We need to discuss this. If like charges are kept at r separation, then also same magnitude of force will act, only direction will be different. जैसे यहाँ पे अगर मैं बोलूँ Q1 पे फोर्स किधर लग रहा है, Q1 पे, so Q1 is getting attracted by minus Q2 here. So on Q1 force is acting on this direction, force on Q1 because of Q2. ठीक है, so this is this. If there are two same charges, let's say two positive charges are here at separation r, again same this value of force will act, but direction will be opposite. So here on q1 now force will act in this direction because it will get repelled by 2. ठीक है, yes Sahana, yes there is a specific value I will discuss. ठीक है, so this k is equal to what? So k is equal to 1 upon 4 pi epsilon. Done it. Let's for now keep it here like this. अब ये एप्सिलन क्या है? एप्सिलन को हम बोलते हैं परमिटिविटी. इसको हम क्या बोलते हैं? परमिटिविटी. Done. So if two charges are kept in vacuum, let's say we have kept the charges in vacuum. In that case, k is equal to 1 upon 4 pi epsilon naught. Epsilon gets indicated by epsilon naught और इसका वैल्यू होता है 9 into 10 to the power 9. Done है? This is the thing. And if media is not vacuum but something else, then this epsilon will be given in your question. Again, but the question is what is this permittivity? ये समझना हमारे लिए ज्यादा important है. So you must have seen fog in colder days, right? In winter season. Suppose कर लो there is one person sitting here, standing here, person A, and there is another person B standing here. ठीक है? If there is dense fog, सपोज कर लो इस रीजन में काफी गहरी गहरी कोहरा लगा हुआ है, डेंस फॉग इज देयर, देन will person A be able to see person B clearly? No. And if fog gets more denser, clarity will reduce even more, right? Then and if the fog become less denser, then A person will be able to see person B. Similarly, in charge thing, we have two charges here, plus Q1 and minus Q2. So how clearly, okay, Monica, how clearly Q1 charge is able to feel the influence of minus Q2 charge in its surrounding will depend on surrounding consists of what? Is it the surrounding vacuum? Is surrounding water? Is surrounding solid? So it will depend on that environment. है ना? And that factor is getting included in the force equation by epsilon. So permittivity talks about how जैसे देखो epsilon naught का value is minimum for vacuum. Epsilon naught value is minimum for what? Vacuum. And in that case, fog is the least denser and one charge is able to see another charge perfectly and hence force is maximum. Epsilon naught is least. इसका मतलब if this is list, k का value आप यहाँ पे रख दो 1 upon 4 pi epsilon q1 q2 by r square. So you can clearly see here force is inversely proportional to epsilon. If epsilon is least, force will be highest. So epsilon is least for which media? Vacuum. ठीक है? Yes, that is in vacuum. Maximum value, okay, that is not it. I mean, there can be different sort of media. So it's not fixed in which media it is the highest, but as media will change from vacuum, epsilon will increase. In air, it will be more than vacuum. In more denser air, it will be even more than that. So I don't exactly know in which media it is the highest or how much is the value, because and also it is not significant here in our discussion. Okay, so we don't need to know that also at the same time. I've never read it somewhere also, but if you're curious you can google it. ठीक है, एक बार गूगल करके देखना, maybe you will be getting some answer, but unfortunately I don't know it right now. I can let you know tomorrow if there exist then. ठीक है, चलो, thank you. So force is what? Inversely proportional to epsilon. As epsilon will increase, force will decrease. Epsilon the minimum value is for vacuum, that is indicated by later epsilon naught. So this is your Coulomb's law. In tomorrow's class, first we will take up one question from Coulomb's law. ठीक है, एक क्वेश्चन अभी Coulomb's law पे हम थोड़ा डिस्कशन और करेंगे, डन है. उसके बाद वी विल मूव ऑन टू नेक्स्ट पोर्शन. ठीक है, क्वेश्चन करना बहुत जरूरी होता है, समझना जरूरी है. वी आर नॉट इन हरी. वी विल कंप्लीट होल सिलेबस थिंग, आई मीन फर्स्ट पार्ट बाय द एंड ऑफ May month. That is not an issue. Thank you, Sahana. Thank you so much. Actually, there's so many classes happening this time, so I'm really tired. I mean, really tired, I would say. Not full syllabus, first part full syllabus. Thank you, Nikita, Monica. Thank you, everyone. Thank you, everyone, for your patience. And I really felt good when you were asking questions. Okay, so it really makes me feel good. You keep on asking question. I never get irritated by questions. When I know, I try to explain. When I don't, I will take time from you. Sorry. ठीक है, थैंक यू, थैंक यू, थैंक यू, थैंक यू. कल मिलते हैं, ढेर सारा कुछ कुछ क्वेश्चंस करेंगे एंड वी विल गेट टू लर्न मोर कॉन्सेप्ट्स. ठीक है, तब तक के लिए तुम लोग अपना ध्यान रखो. और व्हाट इज परमिटिविटी? परमिटिविटी देखो, डेफिनेशन में लिखती नहीं, क्योंकि दैट इज थिंग ऑफ बोर्ड और समथिंग, बट परमिटिविटी को मैंने तुम लोगों को फिजिकल सिग्निफिकेंस में समझाया. सो परमिटिविटी टॉक्स अबाउट हाउ इजिली वन चार्ज विल बी एबल टू सी अनदर चार्ज. सो permittivity defines electrical media, I would say, or defines media in terms of how one charge will be able to see another charge easily or with difficulty. So exact definition I cannot quote, but if you want me तो कल से मैं क्लास में definition भी लिखकर ऊपर रख दूंगी. ठीक है, अच्छे, थैंक यू सो मच. एप्सिलन, एप्सिलन वही है, परमिटिविटी है. ठीक है, एप्सिलन इज परमिटिविटी. संजना, थैंक यू सो मच. साई, अक्षय, थैंक यू. सहाना, थैंक यू. निकिता, थैंक यू सो मच. थैंक यू. साई, समझ में आया? अगर नहीं भी आया है तो कल की क्लास में मैं फिर से डिस्कस कर दूंगी. ठीक है, इट्स नॉट एन इशू. थैंक यू अनु, थैंक यू, थैंक यू, थैंक यू. प्रेम, थैंक यू सो मच. चलो सभी लोग अपना ख्याल रखो, थोड़ा बाहर घूमो, टहलो, इजी हो जाओ एंड डू रीड अ लॉट. ठीक है, प्रैक्टिस करते रहो. थैंक यू रिहाना, थैंक यू. चलो, Joshua, thank you so much. Thank you, people from Assam, people from Andhra, people from Gujarat, people from Maharashtra. Thank you, everyone. Thank Tarun, Pavani, thank you. चलो, सबको धन्यवाद बहुत ज्यादा. Now I am going to end the class. So, everyone, bye bye. Jenny, Haveri, thank you so much. Thank you. Thank you, everyone.